Hello everybody! In this video I'm continuing a series where we will build a real AI-powered system using Microsoft Agent Framework in ASP.NET Core. As we have seen in previous video where we have built a simple AI agent for Bookshop Assistant, AI agent is typically driven by LLM and it has access to various tools to help it to complete tasks. We don't need to waste time implementing full agentic infrastructure, tools management, response management, endless JSON schemas for function descriptions, etc. In this video, I want to show you something even more powerful: workflows. Microsoft Agent Framework Workflow help us build smart automation by combining AI agents with our business processes. So we can create complex workflows easily without worrying about technical details and focus in our main business logic. Okay, here is a project which we built in previous episode. We have book recommendation agent builder. So let's add one more agent builder here. It will be book order agent builder. We will use it to place the order. So let's add build method here, the same as in previous agent builder. So the name will be book order agent. It collects order details and places a book order for the selected book. And instructions: you are a bookshop assistant, you need to help the user to order selected book. Select book ID is available in prior conversation context after handoff, because we already select a book in a previous conversation, and agents need to collect the following information: delivery address and payment method. When information is collected, you must call order book tool and respond with order ID. So we need to inject client in our book order agent builder. We will use the same Azure OpenAI provider as in previous video for this agent as well. Also, we need a book order request with parameters book ID, delivery address, and payment method. It will be populated from order book tool. Also, we need to define this tool. For that, let's create an iBook order service. It will be interface with only one method, order, with parameters the request of this book, offer request, and cancellation token. Don't forget about descriptions, that LLM understands the context. And let's add the implementation. We just respond with order ID, but in real case scenario, we will add here some database to store order in database, maybe send some email, and any other functionality which we need. And let's inject this service here. So we have finished with book order agent builder. And let's now create a workflow builder. For that, let's create a new folder, workflows. And let's also push agents to the workflows. And let's create a workflow builder. First of all, we need to inject our agent builders here. And create a build method. This method will return Microsoft Agents AI Workflows workflow. First of all, we need to build a recommendation agent here and order agent here. Now we need to select an orchestration pattern. Microsoft Agent Framework provides several built-in multi-agent orchestration patterns. It's sequential, that agents execute one after another in defined order. We could use it, but we can apply something more powerful for future flexibility. Next type is concurrent, that agents execute in parallel. And next one is a handoff workflow, that agents transfer control to each other based on context. This one is the most powerful because each agent could talk to any other agent. So let's use this one. So we need to return agent workflow builder and create handoff builder with. We need to set the initial agent, so everything will start from recommendation agent. Now we need to set up handoffs with handoff, and here we need to describe this handoff from recommendation agent to order agent. And hands-off reason. The user selected a specific book and it's ready to place that order. We could also add more with handoffs like this, from, for example, from order agent to recommendation agent in some cases, when, for example, the user wants to change the book. And we could add even more. But as you can see, create handoff builder with is underlined with the red line because this pattern is still experimental, so it could be changed in future, for example, method signature or something else. But we want to use it now, so let's just ignore this notification like this. And don't forget to build it. Now let's create an order book workflow runner. We need it to run a workflow which we have built. So we need to inject here order book workflow builder and implement method run. This method will take a conversation ID, message which user has sent, and cancellation token. First of all, we need to build a workflow. Then, using in-process execution, we will run it. So we run workflow with input of user message. So role of the user is user, and message is message which user has sent to us. And session ID is taken from conversation ID. And cancellation token. After run, we will receive bunch of ongoing events, but we are interested in this case only in the workflow output event. It's almost the last event of the workflow execution run, so we want to pull information from it. The information we are interested in is a message. It's a message which specific agent sent back to us. For that, we need to cast output event message to list of chat messages type, because by default this event contains only the data which type is object, so we need to cast it to list of chat messages. And we take the text from the latest message. Now we want to modify our controller. Now controller is using book recommendation agent builder, but we wanted to use our order book order workflow runner. And instead of this, we just need to run our workflow. So runner, run conversation ID, message, cancellation token. And that's almost it. But here is a very important point, that agents do not share the same session instance because different agent types may have different implementations of agent session abstraction. So we don't need this session thing in book recommendation agent builder anymore. We also don't need iConversation session store. And let's also remove it from the iContainer. And we need something else. We want to store the conversation as it is. So with all messages from user, from assistant, and store it right now in memory, but in the next video we will switch it to the database. Let's add an conversation entity. For that, let's create an entities folder. Conversation needs to have ID and list of conversation messages. Conversation message is a value object with agent. Here will be agent name, role like user, assistant, tool, etc. and list of AI content. What is AI content? So agent is working with chat messages. Each chat message has a list of AI contents. And several types can extend this AI content. We are interested only on 3 of them. First of them is a text content, is just for regular messages like from user to agent and from agent to user. Then function call content, which agent use when some tool needs to be called, and function result content, when some tool was called and we need to send some data back to agent. For example, tool content has just text property, and other are more complex types. So let's back, for example, to function call content. It has name, arguments, which needs to be sent to tool like request in recommendation agent builder. So those properties from book recommendation request like genre, writer, minimum year, maximum year will be there. And call ID. It's also a very important property that agent know which tool was called by this ID. And the last one is a function result content. It has only result object which we are interested in. So that's it. All others are additional and we will not use them in this course. The next thing what we want to implement is a conversation store. Let's create some interface, iConversation store with single method. This method will create or return conversation to us. And let's implement it. Right now we will use in-memory conversation store. We need dictionary where key will be conversation ID and value is a conversation. Get or create method is the same like we did for session storage in previous episode. And now let's back to workflow runner. Let's inject here this conversation store. First of all, we need to create or fetch conversation. Next thing is to add a user message to this conversation. So conversation, add message, new conversation message. We also want to have an executor. We could fetch it from the last message, but if conversation is empty, we could use start executor ID from the workflow, which will be a book recommendation agent. Role will be user, and contents is list of AI content with text content message. We also need to store information about how many conversation messages were here before run, like this. Why we need it? Because this output event will contain all messages from the beginning. Next thing is here that we need to use all messages for input. So we go through each conversation message and convert it to chat message. Now we also need executor here, but for that, let's also cast it to event. So this event will be this one and executor ID. Next thing, we need to go through each conversation message, but skip initial ones and add them to conversation with executor, message role, and message contents. And return the latest message, text content. Last message will be just text content from agent, so we could cast it to text content and use text. So that's it. Now let's register everything in DI container. First of all, new agent builder, then workflow builder and workflow runner. Also, we need to register conversation store and iBook order service. So that's it. Now let's test if everything is working. Let's run our application. Let's go to Swagger. Let's create new conversation, copy ID of it, and use second endpoint to talk to agent, even to workflow. Hi. Welcome. What genre are you interested in? Something in science fiction. Great choice. Do you have any specific writer? And publication years plus execute. Now we see that tool is still working like in the previous episode. Let's select the first book. And as we could see, workflow delegates execution to second agent because only second agent knows about collecting delivery address and payment method. So address and payment method. Thank you for providing the details. Your order for this book will be processed shortly. You will receive updates regarding your order status. As you can see, everything is working as we expected. Now you have a multiple agent system where agents collaborate and pass control between each other. This is already close to production level architecture, but we still have one big problem. Everything is stored in memory. In the next video, we will fix that by persisting conversation in a database and making the system truly scalable. Bye!